Okay, in the left-hand corner, we have angle A is congruent to angle D, and line AB is congruent to line CD. We have to prove that triangle ABE is congruent to triangle DCE. We already know that angle A is congruent to angle D because it is given information, as seen right here. So for statement number 1, it is given information. For statement number 2, we already know that line AB is congruent to CD, so you're going to just put given for number 2. Oh, also, if you put in your markings, it'll help you a lot better, so I should probably put in my markings. We know if angles BEA and angles CED are on opposites on the same two lines, then they are vertical angles, which makes the angles congruent. That is an important part of the proof. Triangle BEA is congruent to triangle CED. Yeah, that's a congruent sign. It's kind of sloppy, but yeah, it looks like one. So anyways, with triangle BEA being congruent to triangle CED, the reason for that is because they're vertical angles. Now to prove that triangle ABE is congruent to triangle DCE, we would have to use the theorem SAA. See how we have one side congruent and two angles? So statement number 4 is triangle ABE is congruent to triangle DCE. The reason being is SAA, or side angle angle. Okay, for this proof we are given that XW is parallel to QZ. We are also given that Y is the midpoint of YZ. So we already know that XW is congruent to QZ because it's given information. So for statement number 1, you're going to say XW is congruent to QZ, as you can see right here. So, and then for the reason being is it's just given. Next, we have angle Q is congruent to angle W, or angle X is congruent to angle Z. It doesn't say this, but we know that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. For statement number 3, we know that Y is the midpoint of YZ. We know that, and the reason for that would be given. Next, we would put WY is congruent to YQ. We know that because the midpoint cuts a side into two congruent sides. Okay, I'm just going to move these up a little bit so I have a little bit more extra room. Okay, next we're going to say angle XYW is congruent to QYZ. I actually forgot that right here, this is supposed to be parallel, not congruent, so I made a little mistake, my bad. So let me change that to parallel instead of congruent. Okay, anyways, what I was saying, angle XYW is congruent to angle QYZ. We know this because vertical angles are always congruent. So for the reason for angle XYW being congruent to angle QYZ, we would say that vertical angles are always congruent. So we would say vertical angles are always congruent. Lastly, to prove that triangle XYW, to prove that triangle XWY is congruent to triangle QZY, we would use the theorem ASA. So let me move this up a little bit. Hold on one second. Move this up. So triangle XWY is congruent to triangle QZY. Reason being, using the theorem ASA. So for reason, you would say ASA. In this proof, we are given E and D. They trisect AC, and triangle ABC is isosceles of base AC. Those are given to us, so we can just write as our statement, E and D trisect AC. Reason being is that it's given. And triangle ABC is isosceles of base AC because it is also given. Now we have to prove that ABE is congruent to CBD. This is more of like a trickier triangle. We know that ABE would be congruent to EBC by using side angle side, because these are, if you look, there's two sides in one angle. But to prove that triangle ABE is actually really congruent to CBD, we would use CPTCT as a theorem. CPTCT is corresponding parts of congruent triangles, and that's what you would use. That's the one theorem you would use. Okay, given angle HGJ is congruent to angle KJG, we already know that that is given information. So for reason number one, we're going to put angle HGJ is congruent to angle KJG, which is given. Also, we know that angle KGJ is congruent to angle HJG, which is also going to be given. Now looking at the diagram, we have GJ is congruent to line GJ. We know this because it shares a line. In that case, we know if it shares a line, it's going to be stated as reflexive property. Reason number three is reflexive property. With that being said, line HG is congruent to line KG. They are parallel. The theorem you would use is SSS, which is side, side, side. So in our last proof, we are given angle A is congruent to angle D, and AC is congruent to line CD. For our first statement, we're going to say that angle A is congruent to D. Reason being, it's given because it was given information right here. Then we have AC is congruent to CD, which is also given because it's given information. Okay, then to prove that C is the midpoint of BE, we know that the two sides, AC and CD, are congruent sides, so if midpoint, then two congruent sides. For reason number 3, we would say AC and CD are congruent sides. So if midpoint, so C is the midpoint, then two congruent sides. So your reason would be sides AC and CD are congruent sides. So if midpoint, then two congruent sides. Okay, so our reason is AC and CD are congruent, so if midpoint, then two congruent sides. And lastly, we know that angle ACB is congruent to angle ECD. They're vertical angles, and the reason that they are congruent is because of the theorem. If you use theorem ASA, angle side angle, you can see the two angles and the one side. Last statement is angle ACB is congruent to angle ECD, and the reason being is the theorem ASA, angle side angle.